Hey everyone, welcome back to Cracking the GRE Math Subject Test. This is Calculus 1. We're on problem number 32. So in this problem we're asked to find the expression that gives the area bounded by these two circles in polar coordinates. And I'll just remind you that when you're looking for the area in polar coordinates, like let's say you have some graph in polar coordinates, r equals some function of theta, and you want to write an integral with respect to theta, and let's say you're looking for this area right here. Then if this is theta 1 and this angle is theta 2, then you're going to integrate from theta 1 to theta 2, and you're going to have to put inside the integral 1/2 r squared, because you can imagine that you're integrating little slices of this area where the width of the slice is d theta, and so the area of the slice is 1/2 r squared d theta. Okay, so we need to figure out, if we look at this graph, we need to figure out what this point is right here where these two circles intersect, because the value of r is going to be different depending on whether you're in this first half of the shaded region or this second half of the shaded region. So the way to figure out what that point is to set these two functions equal to each other. In other words, root 3 sine theta is equal to 3 cosine theta. Well, the value of theta that will make this equation true, well, if you look at the answer choices, it's either 0, pi over 6, pi over 2, or pi over 3. By looking at the graph, it kind of looks like pi over 6. We can check if it actually is. Sine of pi over 6 is, it looks like pi over 3, 60 degrees. So sine of pi over 3 is root 3 over 2. And we got this root 3 over here. And cosine of pi over 3, that's 1/2. And then we've got this 3 here. So yeah, this checks out, because root 3 times root 3 is 3, so we get 3/2 on both sides. So this point right here corresponds to theta equals pi over 6. So if we want to write the integrals, then we're going to have to integrate first of all from 0 to pi over 6. Okay. And inside that integral, our value of r is going to be determined by this curve here, which is the smaller circle, root 3 sine theta. So we're going to have 1/2 root 3 sine theta squared d theta. And then the second integral is going to be from pi over 6. Or sorry, I keep writing pi over 6, but this is supposed to be pi over 3. Right, where you found out that theta is equal to pi over 3. And this is going to go all the way up to pi over 2. And now r is going to be determined by this curve, which is the big circle. So that's going to be 1/2 times 3 cosine theta squared d theta. And that is answer E.